Hi, this is Lily Mitchell from second period, and this is my math project. So it's called Fat Cat vs. Motion, Who Will Win? 30.5% of Americans own a cat. Although house cats don't seem to move much, they possess the abilities to run faster than the fastest man on earth. I tested my cat's Aspen's motion while he chased a ball in my backyard. He moves to the right with a changing speed. Will he tap into his inner power to chase a ball, or will he be the lazy cat he usually is? So here's the motion section. I have an X2 graph, so Aspen's position and time, and at 3 different points on the graph, I've calculated the velocity and the acceleration, and you can see from the steepness of the arrow or the slope of the graph that the velocity at the beginning is a lot more than at the end. The velocity equation is change in distance divided by change in time, and I use that to calculate these velocities, which the boxes are disappearing. For acceleration, the equation is change in velocity divided by change in time, and so I use that to calculate the acceleration. Forces. Here I made 2 force diagrams, one at 9 seconds, so at the beginning of the video, and one at 31 seconds, so at the end of the video. They look similar because in both times Aspen is slowing down, so his applied force is less than the frictional force. Work. Work is done when a force is applied to an object and the object is moved through a distance. The cat does work when he steps and moves himself along the pavement. It is measured in joules, which is equal to a Newton meter. So I have 2 calculations for work, one at the beginning, one at the end, and you can see with the bigger paw that at the beginning the work is more than it is at the end. Energy. There are multiple types of energy. Kinetic energy is the energy of motion and is useful energy. My cat has kinetic energy when he's running. There is also dissipated energy, which the system has when there is friction between the pavement and his paws. So I calculated kinetic energy, which is equal to half mv squared, and I plugged that in and I figured out the kinetic energy was 0.5 or 0.95 joules. And I made an LOL to show energy. At the beginning, he has chemical potential energy because of his food, and at the end, this isn't working. At the end, he has kinetic energy and dissipated energy, but more kinetic than dissipated. And I'm not sure why it's not showing up, but it's on the poster. The system is cat, earth, and ground. And the energy equation is chemical energy is equal to kinetic plus dissipated, because the law of conservation of energy says that no energy can just disappear, so it remains in the system, but it becomes different types of energy. Energy efficiency. Energy efficiency is the amount of useful energy in the system. It's equal to useful energy divided by total energy times 100. So after plugging that in, I figured out that energy efficiency is equal to 70%. Power. Power is the rate at which work is done. Aspen has power when he does work or runs in the video. The equation for power is power equals work divided by time, and my cat's power from 3 to 6 seconds was 0.007 watts after I plugged it in. Improvements. There are always improvements that could be made to an investigation to make the results more accurate. The instrument resolution could be improved upon in order to calculate more correct velocities, position, and acceleration. So my phone camera isn't the most correct thing, so we could get a really good camera and get more correct readings. With any experiment, testing multiple times makes the results more accurate. So testing my cat 5 times instead of 1 would improve results. And testing the cat running on different surfaces may give us a more well-rounded and complete result because friction and running style could depend on the surface. The conclusion. Aspen the fat cat tried motion, and through the results I've calculated, you can see he doesn't like it very much. His velocity is much slower than 9.8 meters per second, which is what a sprinting cat can reach. His power and work were also low compared to what a cat has the ability to do. In this round, the winner is motion and not the lazy cat. And here I have my sources. Thanks for watching.